This is the second half of section 6.3. We'll be doing some phasor calculations. This will be nothing but calculations, and if you're very familiar with this trigonomic functions, you may want to just skip over this portion. If you're not, you may want to pay special attention. We will be solving figure 627, 28, 29, 30, and 31, and these are all the practice problems at the end of section 6.3. Okay, we start out with figure 27, and we're given this triangle. We're given the opposite side of 15, the adjacent of 25, and we're asked to solve for the hypotenuse and the phase angle. So, what we could do, if we look at our sine functions, we'll see if we're given the opposite and the adjacent, we'll probably want to use the tan function. So the tan function equals opposite over adjacent. And we're not solving for the ratio here. We already know the ratio. It's going to be 15 over 25. So we could say we're solving for tan of 15 divided by 25. But like I say, we have the ratio, but we want the angle. So actually, in this one, we would use the arctan. So let's grab our calculator. And first of all, let's say 15 divided by 25 gives us the ratio. And then we want to know the arctan. So we'll go shift and arctan, and that gives us the degrees, 30.96. So that's going to equal 30.96, and that is our degree. So that is our, we know that the angle is 30.96 degrees. So now we want to solve for the two, or the unknown over here, and we could do this a number of ways, but we want to have one that includes the hypotenuse. Let's see, the sine, if we say sine equals O over H, and we know what the opposite is. It is 15. And we need to know, let's see, we know that the degrees are 30.96, but we do need to know what is that ratio for sine. And so we could go in, let's go again with our calculator, and let's say, let's go in with our value. We've already got it in there, 30.967. Let's get the sine of that, and that is going to be 0.514. So we'll say 0.514 is going to equal, and let's see, we're given the opposite is 15 over H. And we're solving for H. And let's see, we could just say that H is going to equal 15 over 0.514, but let's actually solve it algebraically. So what we could do, we could say we could multiply this side by H over 1 and this side by H over 1, and this would eliminate the H over here. So then we'd have H times 0.514 equals 15, and then we could divide each side by 0.514, and that would say H equals 15 divided by 0.514. And so if we got our calculator and we said 15 divided by 0.514, we would get 29.183. So 29.183, and that should be our solving for H right here. So we said our angle was, let's see, 30.96, and we said our hypotenuse was 29.183. Now, in the end of this chapter, all of the answers there, you could check your answers there, but we could do it another way. We could use the Pythagorean Theorem, and that will say that the square root of a square, or the adjacent squared plus the opposite squared will equal the hypotenuse. So if you take the square root of this, so let's do that and use that as a check. So we could say the adjacent square, let's see, that's going to be 25 squared plus the opposite squared, which is 15 squared, equals this value, and then we said the square root of that would equal the hypotenuse, so the square root of that, and there it is, 29.1, and we're very close, and we had a little bit of rounding here because we had several decimals we didn't include, but 29.15 is very close, and that confirms our answer for figure 27. Okay, let's go to the next one, figure 28. In figure 28, we are given 75 degrees as a phase angle. The adjacent angle is 4. And so we need to solve for B and C. Now we could address this a number of ways. Let's see if we want to address either the opposite or the hypotenuse. Why don't we take the tangent? Let's do the tan. And tan equals opposite over adjacent. And we have the adjacent value, which is 4, but we don't have the O. And we have the degrees, so we can solve and get the ratio for the tangent. So let's do that. Let's go and say the 75, and the tangent yields 3.732, so we will say 3.732 equals the opposite over 4. And let's see, if we were to solve for this, we could take this side times 4 and this time times 4, and we would find out that the opposite is going to equal 3.732 times 4. And why don't we grab our calculator, and we have, okay, and we take that value times 4, and we get 14.928. Okay, 14.928. And we were solving for the opposite, so that is this value right here, 14.928. And now we need to solve for, let's see, we need to solve for the hypotenuse. And we could say, let's see, we could use a sine function to do that. Sine equals the opposite over the hypotenuse. And the hypotenuse is 14 point, or excuse me, the opposite side is 14.928. The hypotenuse is unknown. The sine function, let's get our sine function. We have 75 degrees. We'll take the sine of that, and that is 0.965. So if we had 0.965 equals 14.928 over h, and we could solve for this, and we'd find that h is going to equal 14.928 divided by 0.965. And if we did that with our calculator, let's see what that is. We have 14.928 divided by 0.965, and that equals 15.46. And that would be our hypotenuse. And so, again, we could test our values. We say the opposite is 14.928, hypotenuse 15.46, and the adjacent is 4. So if we go in with our calculator, we could say 4 squared plus 14.928 squared equals, and then if we took the square root of that, 15.4, and that is what we would expect to see. Again, answers are on the back of the chapter. Okay, we're at figure 29, and here we have 10 degrees. We're given as the phase angle. The opposite is 1,000, and we're solving for A and C. So, let's see, we need to solve for either the opposite or the hypotenuse, and we are given either the adjacent or the hypotenuse. So let's see, we're given the opposite. Why don't we use the sine? Sine equals the opposite over the hypotenuse. The opposite we're given is 1,000, and we're solving for h. So let's see, our sine is 10. We have a 10-degree phase angle. Let's get our calculator, and let's see, we need to get 10 and the sine, and we get 0.173. So we have 0.173 equals, it's going to be 1,000 over h. And if we were to solve for this, we would find that h is going to equal 1,000 divided by 0.173. And so let's go ahead and do that. So we will say 1,000 divided by 0.173 equals 5,780, and that will be 5,780. That will be our hypotenuse. And now we need to solve for the adjacent angle. And the adjacent angle, let's see, how should we do that? We've got, we know the opposite and the hypotenuse. We want to know the adjacent. We could do a tan function here, which is the O over A. We have the opposite, which is 1,000. So we would need to solve for the tangent of 10 degrees. So let's go up here and say 10 tan, and we get the 0.176. So 0.176 would equal 1,000 over the adjacent. And we could go ahead and solve that, but the adjacent angle will be 1,000 divided by 0.176. So let's solve for that. So we have 1,000 divided by 0.176 equals, and it's 5,682, and that will be the adjacent angle. Let's see, 5,682, maybe we'll write it here too, 5,682, And again, we could do our Pythagorean theorem just to confirm that. So grab our calculator and we'll say 5,682. I already have it there. Let's square that. Plus 1,000 squared, 1,000 squared, and that equals, and then we'll take the square root of that, and 5,760. And okay, that's close to this value. We did a little bit of rounding because we didn't use the decimal points, but we're quite close to that value, and that will be satisfactory. Okay. Solve figure 30. So figure 30, what have we got here? Here we have a phasor, and we're looking at, and if we look at this, we can draw some relationships to what we have just been doing. We have the VP, this is our phasor from the beginning of this chapter, and this is the hypotenuse that we've been talking about. So we have, and we also have and this is the opposite angle, and this is the instantaneous voltage, and this would be 10 volts. Now, if we look at our, let's see, sine, cosine, and tangent, let's see, we have the opposite in the hypotenuse, so that would equate to the sine. So we have the two values, the 10 and the 25. Now, what we're solving for here is what is the value of the angle. We don't know what the value of the angle is. So the sine function here, remember when we do sine, we say sine of degrees, and that gives us the angle, or the ratio. But we have the ratio, so in this case we're going to do the arc sine of 10 over 25, and that should give us the angle. So let's go in and again grab our calculator. And first of all, we will say 10 divided by 25 gives us our ratio, and then we're going to take the arc sine of that, and that gives us 23.57. So that would be 23.57 degrees, and that would be our answer for what is the angle given 10 volts instantaneous over 25 volts peak. And then our final one here, we're going to be looking at a different part of the phasor. And in this case, we have the voltage peak is 25 volts. The instantaneous value is 45. But again, we have the same two variables. We have the hypotenuse and the opposite, and again we would be using the sine function and the let's see again, but this time we have a minus 45 volts, minus 45, and the peak value is 100. And again we have the ratio, so what we would want to do here is the arc sine. So again, let's grab our calculator, and first of all we need to say 45, and it's going to be a minus 45. I need to keep our signs accurate here, divided by 100, and that would give us this value. And then we need to do the arc sine of that, so we go shift and arc sine, and so we're going to get minus 26.7 degrees. And that will be our answer for this. Keep in mind, all of the answers to this are in, or all the answers to these practice problems are in the back of the chapter. You'll have many more problems in the regular problems at the end of the chapter, and those are part of the assignment. So this was just a practice session with phasors, and we looked at figure 31, 30, 29, 28, and figure 27.